Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 11B assignment. Okay, so first one, use your calculator to select a random sample of 6 different numbers between 5 and 25 inclusive. So we can do this on a scientific calculator and on the graphing calculator. I find it a little bit nicer on the graphing calculator. They give you a little bit more options, but you can still do it on most scientific calculators. So on the TI 30s, what we got to do is, this is going to be, I believe, under, is it probability? There it is, probability. We go over to random, and then we don't want just random, because then that could be any kind of number, but we want random integers. So it says 6 different numbers between 5 and 25 inclusive. So it doesn't say it specifically, but it appears to imply that it's should be integers instead of just all sorts of numbers. So we're going to do rand int, because that stands for random integer. And then we want to go from 5, and then we're going to do comma. Always separate it with a comma. So 5 is the lowest, and then 25 is going to be the highest. So we'll do 5 comma 25. Our comma is right above the period there, so we have to do second decimal, and 5 to 25. Close that off. And then every time we push enter, it'll give us a new random one. So 14, 23, 20, 24, 10, and I think 20. I think that gives us all of our random numbers there that we want. Okay? Okay, we can actually also do it on the graphing calculator, and these make it a little bit nicer. We are going to go into, I believe it is, shoot, I can't even remember. Math, there it is. So math over here at probability is what we're looking for. Okay, so there's random, and then there's random integer. So what we want to do is we want to go down to random integer. And when I enter this, some calculators will enter into this lower, upper, and then n, and then pace, and some won't. If it doesn't, then the first number you want to put in is the lower bound. In this case, it's 5. And then we put a comma in. Oh, not a comma on this one. If you didn't have this screen show up, then you would push comma. Delete that. And then the highest that we want to go is to 25. And then we're going to, over in this question here, it asks us to come up with 6 different numbers. So I'm actually going to put in 6 here. And I'm going to push paste. So again, if you did not get the screen, yours would be rand int, and then have parentheses 5 comma 25 comma 6. Okay, and look, there it is. So it would look just like this: 5 20 comma 25 comma 6. Push enter, and it will give us 5 different numbers between and including. As you can see, there's a 5 in there, and including 25. Okay, so we can write those down, I suppose, if we want to. 5 12 25. And then also 9, 21, and 24. Okay. 10 different numbers between 1 and 25 inclusive. We can do that too. Same idea. I'm going to use the graphing calculator just because I find this to be a little bit easier, a little bit nicer. 10 different numbers between 1 and 25 inclusive. So if you remember, we went into math. We went over to probability, and we did random integer. Number 5. Okay, so now we're going from 1 to 25. So we do 1 to 25, and now we want 10 different numbers. We push enter, and then enter once we get to that, and now it'll give us 10 different numbers. Okay? Okay, so we end up getting these here. All right, moving on to the next one. 4, an annual dog show averages 3,540 visitors. The catering manager is conducting a survey to investigate the proportion of visitors who will spend more than 20 pounds on food. I think that's what that is. Is that pounds? I don't know. And drinks at the show. He decides to survey the first 40 people through the gate. Identify the sampling method that is used. Okay, so sampling method used is he's taking the first 40 through. That is what we call convenience. Convenience sampling. Okay, when you're just taking like a the first group that you can get. It's just getting whoever that you can in there. Okay. Discuss any problems with the sampling method. Well, problem is this is the first people in at the show are going to possibly be there longer, and they're also going to be there probably before the show even starts. So they will, chances are, the first people in are probably going to be spending on the higher amount because they're again, they're going to be there longer. They're going to be a little bit bored at the beginning, so they're going to, it's like, hey, let's go get something to eat while we wait for the show or something like that. Okay. And then C, suggest a better sampling method that includes a suitable sampling size, which better represents the population. That's where you'd want to take maybe systematic sampling. So it's like, I'm going to take every 10th person that comes through the gate, and then maybe even, it's like, okay, I'm going to start with the 7th person, and then I'm going to count every 10 after that, something like that. Okay. Okay, so here's our answer written down just so that we've got record of that. Next one we're going to take a look at is 8. Mona wants to gauge the opinions of her peers on the design of the school's yearbook. She uses her own homeroom class as her example. Explain why Mona's sample is a convenience sample. Well, she's there, so it's a lot easier for her to take the sample out of a class that she's already in instead of having to get out of the class and go somewhere else. So it's easiest for her. That's why it's convenient. In what ways will Mona's sample be biased? Well, part of it, it's like she already knows these people. They might not want to hurt her feelings, and so they might be, a little bit more agreeable with her. And then also this is, her class could be a class full of seniors, and that, might not be necessarily representative of the rest of the class. Okay. Okay. And then suggest a more appropriate sampling method that Mona should use. So she could maybe, go to lunch and again get the survey every 5th person or something that comes by, or she could randomly select 2 or 3 classes and take surveys within those classes. Okay, that'd be more like a stratified sample of students from every class. Okay. Okay, and then last one we're going to take a look at number 10. 200 students in years 11 and 12 at high school were asked whether or not they ever had smoked a cigarette. The replies received were no, yes, so forth and so on. Okay. Why is this considered to be a census? This would be a census because you actually asked every one of the 200 students here. Okay, because that's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 times 1, 2, 3, 4. That is all 200 students were surveyed. That's considered to be a census because you surveyed everyone. Everyone at least in the group that you want. Everyone in group. Target group, we'll call it. Okay. There we go. And then find the actual proportion of all students who said they had smoked. So really what we need to do with this, we just need to count up all the, well, we know there's 200 total, so we can count up, say, all the N's and all the Y. Probably don't have to count up all the Y's. Let's just count up all of one or the other, and then we can do the math from there. Okay. So I went through and counted them all up, and what we had on this one here is 96. Okay. So there's 96 total yeses. That means there's 104 no's. But the actual portion of all students who said they had smoked would be 96 out of the 200, which is 0.48 or 48%, however you want to look at that. Okay. All right. That's all there is for 11B. If you have any further questions, please feel free to ask. Thanks.